Hello dear friends. In this session, we'll get to know the functions available in GitHub Actions. The first functions we'll look at are the ones that check the status of a step. Let's head to the editor and create a new workflow. Since the functions we want to look at are responsible for checking the status of a step, we need a job that has several steps, and in those steps we'll be testing a specific status, a specific state of the step. We'll be working with the following functions. The function that will determine that our step has failed. A function that will determine that our step has succeeded. Moreover, the success function is always applied by default. We'll be using if construct. So the if in steps by default uses success. Next, we'll use the always function, which returns true in any state. And we'll use the cancel function, which returns true only if we've completed the given job. For example, by clicking a button in GitHub Actions, I'll attach the documentation for these functions to the lesson. It includes descriptions, so you can check it out further. Let's get back to our code. So as I said, we need several steps. So I'm creating a job. The ID will just be job. I'm going to run it on Linux. And I'll specify a few steps. So for the first step, let's set a timeout, so that we have a little bit more time to manually click the cancel workflow button to test this cancel function. So I'm writing sleep 30. The next step, we would like to run it on cancellation, like a manual cancellation, for example. So I'll specify the name that it will run on cancellation. In the next step, I will need to perform this check. So I am writing the condition if and using the cancelled function. The cancel function will return true if any of the previous steps were cancelled. If nothing was cancelled, this particular run simply will not execute. In this specific run, I am just going to print some text to understand which step has started. We're going to output this text. If cancel returns false, then this step will simply be skipped. Let's indeed write the next step. The next step will simply use the always check, which will always return true in any case. So let's easily copy the text that it runs in any case. I'll also mention that it actually runs in any case. And I'll change the function like this. Next, for success, let's also write a step. Runs. After achieving success, we can proceed to carefully write the final step of the process. It is crucial to note that if any error occurs during the previous step, this particular function is designed to return a true value. This return value serves as an indicator that something went wrong, allowing us to address the issue promptly and ensure the process continues smoothly. Therefore, understanding this mechanism is essential for effective error handling and successful completion of the task. And only in this case will this step work. In all other cases, it will simply be ignored. Now let's carefully and meticulously push these changes to the repository and thoroughly check what specific values these functions return. Consequently, we will also determine which particular commands are being executed in the process. So, in the previous lesson, I didn't turn off the execution, so we didn't disable the 12th workflow. Let's open the 13th one that we're working on right now. So, the first step is currently running so that we can press this button. I'm not pressing it yet. I want to see what happens when the first step completes successfully. While this is running, I'll disable the 12th workflow from the previous lesson. So the 12th workflow Let's turn off the execution and go into this 13th workflow that just ran. It completes successfully, and looking at the first step, we just had a timer. The second step is skipped because it was cancelled, which means the if statement returned false, so the runner and the command didn't execute. The runs on any case executed because it always returns true in any situation. The runs on success also returned success because there were no errors, and the runs on fail is skipped because we didn't have a failure. I think everything is pretty clear here. Now let's run all these jobs again, but this time, while it's running, we'll manually stop it. As you can see, after pressing cancel, the operation was interrupted, and in this case, the runs on cancel function returns true, so the command executes. On any case, the command executes in any case, regardless of the situation or circumstance. Success is skipped, and failed is also skipped since there wasn't a failure. It was cancelled. Let's simulate a failure in this context. So instead of sleep, we're going to simulate a failure in this particular case. Let's push this. Let's go to actions. Let's go into it. So, the job finished with a failure, and looking at the first step, there's an error. The cancelled is skipped because it's not a cancellation, it's an error. The any case triggers in any situation, the success doesn't trigger, but the runs on failed. Notice that it triggers successfully. The principle of these functions is really simple, and you can apply them not just at the step level, but also between jobs. So I can just go ahead and simply create a second job right now. This second job is going to run on Ubuntu, which is a popular open source operating system known for its stability and security. And it will depend on the first job, ensuring that all necessary prerequisites are met before execution. So, I'm passing the IT guy from the first job here, which means that the same technical expertise will be utilized, so this job will wait for the previous job to finish, ensuring a seamless transition and continuity in the workflow. And here I want to run the second job only under certain conditions. And let's say I'm interested in the conditions that if this job fails, then I'll have some backup plan and I'll write some commands only in that case if it fails. So, I'm using this item because it provides the features I need. It's effective and reliable for my purposes. And I'll write the steps. In this particular step of the process, you will observe that there will be a notification or message output indicating that the job or task has unfortunately encountered an error and was not completed successfully. Let's commit right now, please. As you can clearly understand, we still indeed have an exit, which essentially means that failed will definitely trigger, and therefore this particular job should also run. As you can see, the second job is waiting for the first one to finish. The first one with the error has completed. The second job is currently running. The second job has completed successfully. And so, the text that I specified is displayed on the screen. And now, let's assume we don't have an error here. Overall, we're removing this step from here. Now, let us carefully observe and see exactly what will happen in this particular case. The workflow is starting, and the first job is still running. The first job ran perfectly, there are no errors, and therefore the second job is simply skipped because we have a condition to execute steps only if the previous job had any errors. You might logically wonder if this function checks the steps overall. If any of the previous steps had an error, but can we check a specific step for an error? And the answer is, of course, yes. So, let's bring back a step that will generate an error for us. This will be our name. and it will generate an error or issue or problem. Now, how do we create a link so that this function checks specifically this step in the process? We need to assign it an ID. We write the ID, set it, for example, to error step. Well, it's clear that logically we won't name error step because we don't mean that there will be an error there. It's purely my decision right now for demonstration purposes to do it this way. And now, where we want to introduce the error, the current structure checks all the steps overall, but if I'm only interested in this specific step, then I need to add an additional condition here. I refer to the context of the steps, selecting which specific step, meaning my ID is this one. And for my ID, I need the key conclusion. It is precisely in this conclusion that the result of the execution will be stored. And in my case, I need to carefully examine this result for such a match. And notice why I'm, in particular, adding this condition to the overall check instead of removing the overall condition. So we have a note in the documentation. Here it is. And we need to add to the if condition if we want to check this negation against the function itself, because if statement, if doesn't have any function to check, it will default to always inserting success. So it turns out that if I don't write it, technically it will say success like this. And as you understand, success will return something completely different, and the condition will lose its logic for this reason. It's done this way for demonstration. Let me change the ID, and this condition won't work. But as you can see, it immediately gives me an error. You see, this extension understands that there is no such step, but I'm doing this on purpose so that this one doesn't run. We started the run. Let's check. Currently, the workflow is working. However, it seems that we are experiencing an issue as we're getting an error. But please note that the onFail step isn't running or being executed. Why? Because right now I'm setting it up so that onFail only runs on a step that has this specific ID. And our step doesn't have that ID. But if I set the same ID, then essentially this step should work now. Let's test it one more time. Let's move on to the action section. Begin by opening it up carefully. After that, wait patiently for the process to complete. This might take some time, so be prepared. During this period, you can review previous steps or plan ahead. It's crucial to let the system finish without interference. Great! So we had an error, but unfortunately the run failed also completed successfully as expected because the error occurred in the specific step where we requested the error check in the process. At the moment, as we anticipated, as for the status functions, we've looked at all of them and tested them out. In GitHub Actions, there are several other functions. We've already worked with some, and we'll be working with others in the upcoming lessons, so I won't be demonstrating them in this lesson anymore. But there's a link in the lesson description, and you can even go check out what additional features are available right now. There are very few of them, just a handful, but we'll definitely be using them in future lessons. Some of them we've already used, like here.json, the format and contents we'll be using. In general, keep in mind that there are additional functions available, and we'll get familiar with them in the upcoming lessons. That's all from me. See you in the next session.